Let's solve this inequality. So we see that we can rewrite the inequality so that we have a quadratic polynomial in standard form on the left-hand side and 0 on the right-hand side, like that. So we are asked to solve the inequality f of x greater than or equal to 0. So we can do this using the method we just discovered. In fact, we can use that method to solve all of these inequalities. Let's do this. First, let's use whether the graph opens upwards or downwards. So what is A here? A is 6, which is positive. So right now we know that the graph will look like this. And what about the discriminant? Whether the discriminant is positive, 0, or negative tells us at how many points the graph intersects the x-axis. The discriminant, which is always b squared minus 4ac, here equals this, and we can find this exact value pretty quickly. Let's do that. 1 plus 24 is 25. All we need, of course, is the sign of the discriminant. The discriminant is positive, so that tells us we have 2 x-intercepts. And as we saw, that means that the graph intersects the x-axis like that. For the x-intercepts, those are the points on the graph. The y-coordinate is 0. They correspond to the solutions of this equation. So let's solve this, try to solve it by factoring. Does 6x squared plus x plus 1 factor? Or is it prime? Let's try (3x plus 1 times 2x minus 1). We have to check. Here we get minus 3x plus 2x, which is minus x. We want positive x, so this does not check. So let's try something else. Since we wanted a positive x instead of a minus x, which is what we got, let's just switch the signs over here. Let's check. We get 3x minus 2x, which is positive x. So this does check. So this factors as 3x minus 1 times 2x plus 1 we use the zero product principle, and we get two solutions. So those solutions are the x coordinates of the x-intercepts and now we can give an answer to the solution set to f of x greater than or equal to 0. So we see that the function is positive on negative infinity to negative 1/2 and 1/3 to infinity. So now we have a greater than or equal to inequality. So we include any endpoints that correspond to x-intercepts, which both of these numbers do. There's the solution set. So for when the function is less than or equal to 0, we see that the graph is below the x-axis. On here. And we include the endpoints because they correspond to x-intercepts. And we have a less than or equal to inequality. So for f of x greater than 0, we have this. We don't contemplate including the endpoints because it's strict. And here we don't contemplate including these endpoints, again, because it's strict. So the solution to this original inequality is that